Hi everyone, in today's video we are going to graph two types of functions, square root functions and also cube root functions. In this video we are going to do a little bit of work with the domain of square root equations, and then also of course we're going to graph the parent functions and use transformations for the families of both square root and cube root functions. Okay, so let's go ahead and get started talking about square root functions. You will notice that this formula that I've given you here has a lot of familiar pieces. It has the a value, which is the vertical stretch or compression, and we still have h and k, which is going to give us our starting point, our initiating point here. So if we look at our parent function, y is equal to the square root of x. If I think about what a, h, and k are, I'm going to rewrite this. This is a times the square root, so the number out here being multiplied is just 1 because it's not changing it. 1 times. The h value being subtracted from the x is nothing because there's nothing there to be taken away. And then the k value being added onto the outside is 0. So with that in mind, we have a, h, and k. So for our parent function for the square root, hk is going to be 0, 0. And we'll come back to these characteristics after we get this graph. So I'm going to plot 0, 0 on the graph. And then something that I want you to notice is that, remember, square roots are the inverse of a square. So we remember how when we were working with quadratics, x squared, and that gave us that nice U shape. Well, with square roots, we're going to be looking at the inverse, or the flipped version. The x and the y's are going to trade places. So we're either going to have the top half of a sideways quadratic, or the bottom half, one or the other, not both. We can't have both because then it would fail the vertical line test and it wouldn't be a function. So let's look at our possibilities. I'm going to put 0, 0 up at the top, and then I'm going to plug in numbers to the right because our square root functions are almost always going to open to the right, either the positive side or the negative side. And another way of thinking of that is the increasing side or the decreasing side. Okay, so I'm going to pick 1, 2, 3, let's do 4 as well. Okay, so when I plug in 1, the square root of 1 is just 1, so that means that ordered pair is 1, 1. When I plug in 2, I get the square root of 2, that's going to be an ugly decimal. Square root of 3, that's going to be a decimal as well, but square root of 4 is 2, so that's another one that I can plot, 4, 2. Now something that I want you to notice here as we get this half of a inverse of a parabola. If we turn our heads 90 degrees so that this looks like it's the vertex, notice that we went over 1 and up 1, and then when we went up 2 units, we went 4 units. If we were to go up 3 units, we would go over 9 units, and our next point would be there. We've still got this squaring function going on. The x's and the y's are just flipped. So instead of going over to the left and right and then up, I'm going up and then over. So you can draw the table if you want, or you can follow the same squaring pattern that we did all through Unit 4, just on its side and only half of the parabola. Okay, so let's talk about characteristics. Our x-intercept is this origin point, so that's 0, 0. It's also our y-intercept. Our domain remembers the x's to y's, it's left to right. So this first ordered pair on the x-axis, that starts at 0 and it includes it. And the function goes infinitely to the right, so that's to positive infinity. We could also write this as x is greater than or equal to 0. The range starts at that origin point as well and goes up forever, so that is also 0 to positive infinity. Be sure if you're writing the range as an inequality, you write y is greater than or equal to 0, because remember range is y's. Increasing and decreasing, we are looking at the x's from left to right. If I start on the left and follow this graph to the right, then I'm going uphill, so that means it's increasing starting at 0 and going all the way to the right. It is never decreasing. Okay, so let's look at a couple of transformations. We're going to take this graph here and move it around depending on what A, H, and K are. So looking at this first one, we have H of -1. Remember to always change the sign on that H, and the K value stays the same, so it's still -4. So I'm going to graph -1, -4. The A value on this one is just 1, so I have a regular square root function. There's no stretching or compressing here. So I'm going to follow that pattern rather than drawing the table again. So I'm going to go up instead of over 1, and 1 squared is 1. Then I'm going to go back to my origin. I'm going to go up 2. 2 squared is 4. I'm going to go back to my starting point. Up 1, 2, 3. And 3 squared is 9. So that gives me my square root function. Now notice on this one I need to go up 1 more to get to my x-intercepts. So I want to take this as an opportunity to review how to use Desmos. So I am actually going to X out of this, and let's plug this one into Desmos to get that answer. Okay, so I'm going to open up Desmos here, and I am going to type in my equation. I've got y is equal to, I've got my square root button right here, x plus 1, and then I need to move outside of this fraction bar to continue typing. You can either hit the arrow or you can click out here and it will move it up, and then I've got my -4. Okay, so I have my graph here, and I'm looking for the x-intercept. So I'm going to look along this, and then it looks like it's at 15. Remember, you can click, and you should have a 0 for the y value if it's an x-intercept. So let's go back to my graph now, and we'll put in 15, 0. Remember, you can also do this in the calculator by hitting second trace and going to that zeros option in that screen. For y-intercepts, that one's easy. That's 0, -3. I don't need to use Desmos for that. The domain, on the left side, it starts at -2, and it's a solid circle, so it includes -2, and it goes all the way to the right, so that's positive infinity. The range starts at that origin, which is at -4 with a hard bracket, and it goes all the way to the top, so that's positive infinity as well. This one is increasing from -2 to positive infinity when I read from left to right, and it is never decreasing because it's never going downhill. All right, let's look at one more of these. This one, h is -2 and k is 0 because there's nothing being added on outside of that radical. Notice that there is an a value of -1 on this one. So this is what I was talking about earlier. It's either going to be the positive side or the negative side, the increasing side or the decreasing side. Notice that all the ones that we've done so far, the a value was positive, and so we had an increasing line here. Because this a value is negative, we're going to have the lower half of the parabola, the decreasing part of our square root function this time. So I'm going to go to 2, 0 and plot my starting point, but instead of doing the top half this time like we have been, I'm going to do the negative side, this side down here. So I'm going to go down 1, and 1 squared is 1. I'm going to go back to my initiating point, down 2. 2 squared is 4. Back to my initiating point, down 3. 3 squared is 9. And then I have my square root function. So for this one, the x-intercept is -2, 0. The y-intercept is not a pretty number, so let's put this one in Desmos as well. Okay, let's see. So we have, okay. Let's do y. Oh, let me close that one out. Okay, so we have y is equal to, what was this one? Negative square root of x plus 2. Plus 2. Okay, so now with that, let's see, we were trying to find the y-intercept, so I'm going to click, and then it's going to suggest that to me. Click on it again, negative 1.414. All right, so that is what we need for that y-intercept answer here, 0, negative 1.414. Okay, the domain for this one, it starts on the left at negative 2 and goes to positive infinity. Remember, we could also write this as x is greater than or equal to negative 2. The range, this one is going all the way down, so the bottom is at negative infinity, and it has a top at this initiating point, which is at 0, and that the 0 is included. So we could say y is less than or equal to 0. This one is not increasing when I look at it from left to right. It is decreasing. The decreasing starts where the x is negative 2, and it decreases all the way to the right. Okay, so let's talk about domain just a little bit more, because if we want to figure out the domain, we don't have to graph it to get there. If we have to answer all these characteristic questions, then we want to look at a graph. But if we're just asked a domain question, because it's a square root function, there's a pretty quick and easy way to do this. We learned in Unit 4 that the square root of a negative number does not exist unless you're using complex numbers. And here's the great news. Square root functions, they're not going to use imaginary numbers, so we don't have to worry about a negative inside of the radical. But that means that if we are looking at a square root function, that the domain does not exist over in this area here, because there's no piece of a graph there. If I look in my calculator at the table for any of these areas are all going to say error, where all of the x's are these negative values, because there's no graph over there. So when we do our domain and say like x is greater than or equal to negative 2 for this one, what we're saying is that if we look on the other side of negative 2, the negative 3, negative 4, negative 5, there's nothing there. So the part that is inside of the radical, the square root, that is the part that can never be negative. So if we can identify where the radical or the radicand is not going to be negative, then that will tell us the domain. So here's how we do that. If we take the radicand, x minus 5, and say this has to be greater than or equal to 0, because it can equal 0 or it can be bigger, but we cannot have a negative number inside of the radicand. And then if we solve this for x by adding 5 to both sides, we get that x is greater than or equal to 5. And that is the domain. It's saying that the x values are all going to be from 5 to positive infinity. Let's look at another one. We have a square root, so we can use the same thing. The 2x plus 3 radicand has to be greater than or equal to 0. So if we subtract 3 first, and then we divide by 2, we know that our domain has to be greater than or equal to negative 3/2. So negative 3/2 all the way to positive infinity is our domain. And you can write these in either format. All right, this last one has a rational exponent. So let's convert that to a radical first. We're looking at x minus 4 with the power of 1, and it's a square root. So we've got a square root, which means that that radicand, x minus 4, has to be greater than or equal to 0. When I solve that for x, I get that my domain is that x has to be bigger than or equal to 4. That means then on my graph, wherever the initiating point is, it's going to get bigger from there. There's nothing over here because the domain is not allowed to have a negative radicand with the square root function. Okay, so let's talk about cube root functions now. In the same way that square root functions were the inverse of a square or a quadratic function, cube root functions are going to be the inverse of a cube. So recall that Recall that we worked with graphing this function, x to the third, and we got a graph that looked like that. So with our cube root function, this is going to flip, and we're going to have a function that looks like it's that guy turned over or flipped over onto its side. Notice in the formula, we still have a, h, and k. They do the same thing as always. So let's look at the parent function first. Our a value is going to be 1. We're multiplying by the cube root of x minus h is going to be 0, and there's nothing added onto the outside, so that's going to be 0, 2. hk is 0, 0. That's here. Let's draw a table. Because this one goes infinitely in both directions, I'm going to put 0, 0 in the middle, and then let's pick some values nearby. Let's pick 1 and 1. And then we'll do -2 and -2 or +2, and then I'll show you some other quick things that it's going to make this less ugly. Okay, so if we put in 1, the cube root of 1 is 1, and the cube root of -1 is -1. The cube root of 2 is an ugly fraction, so I'm not going to graph that. If I go all the way out to my next perfect number, though, since this one has the center point at 0, 0, I'm going to go out to 8, because the cube root of 8 is 2. 2 to the third power is 8. And if I go out to -8, the cube root of -8 is -2. So let's see, that means that at 8 I'm up at 2, and at -2 I'm down at -8. That's going to give me this shape here. Okay, something I want you to notice. If you turn your paper 90 degrees so that this is the bottom and this is the top, then you'll see that if we start at the initiating point, we go up 1, 1 cubed is 1. Go back to the initiating point, go up 2. 2 cubed is 8. If we go up 3, 3 cubed is 27. So we can use that cubing pattern the same way we were using the squaring pattern on its side to get these graphs. And we're going to do that instead of the table just because it's going to make it a lot easier than having to figure out where we'll get nicely working out radicals. If you don't want to simplify a bunch of radicals, the pattern's going to make it much easier. Okay, so x-intercept is 0, 0, y-intercept is 0, 0. This function goes infinitely to the left and infinitely to the right, so the domain is all real numbers. Fun fact, that's always going to be true for cube root functions. The range, this side goes down forever and this side goes up forever, so that's also going to be all real numbers, and that is also going to always be true. Increasing and decreasing, it's going to do one or the other. So this graph is going uphill when I read it from left to right. So that means the increasing is happening negative infinity to positive infinity. The decreasing is never happening. All right, let's do a couple of examples a little more quickly now. So hk in number 6 is going to be -2, 3. That's going to put my center point there. And then I'm going to follow the pattern for the rest of my points. So I'm going to go up 1, and then 1 cubed is 1. Then I go back to hk. Up 2, 2 cubed is 8. So I'm going to go over 8. Then I'm going to do the same thing going down and to the left. 1 cubed is 1. 2 cubed is 8. So then I've got my graph there. And I can answer some questions. It looks like my x-intercept is going to be off the graph, so let's go real quick to Desmos, or if you want to go to your calculator, you're welcome to do that too, and get what this graph looks like. So we are doing y is equal to... All right, now I've got to get a square root or cube root. I'm not going to use this square root button. I'm going to go to functions and then over to miscellaneous, and that's where I have my put in any kind of root that I want. I can type in my 3 and then I can move my arrow over and get my x plus 2. Okay, I'm going to move my arrow over again, and then my plus 3 comes on the outside. All right, so let's see. We're trying to find the x-intercept, and it's going to be way out here. I'm going to keep scrolling a little. Oh, and it looks like if I click, it suggests that it's at negative 29. So let's go back, fill that in. Okay, so we've got negative 29, 0 for the x-intercept. The y-intercept also looks like it's not pretty, so let's go back out one more time and see. Let's zoom out some and slide over. The x-intercept is at 4.26. I'm sorry, did I say x-intercept? I meant y-intercept. The y-intercept is at 4.26. The domain is going to be all real numbers because it goes infinitely to the left and the right. The range is also going to be all real numbers. This one is going uphill the entire way when looking from left to right, so that means it's increasing from negative infinity to positive infinity, and it's never decreasing. Okay, so this next one, number 7, this one has an a value that is vertically stretching it. HK is 0, 0, so that's nice and easy, but we have to stretch up how far we are going up and down to graph. So normally I'd go up 1 and then 1 cubed over, but because of this 3, I am going to instead go up 3 and over the same amount. And then instead of going up 2, and 2 cubed is 8, so over here to 8, rather I'm going to double or triple how far I go up. So 2 times 3 is 6, and then I go over the same amount that I always do. So I get a much taller or more vertically stretched graph. Instead of going down just 1, I'm going to triple it and go down 3, but still over 1 cubed. Instead of going down 2, I'm going to triple it and go down 6, but 2 cubed is still 8, so I'm going over 8 units that way as well. And this gives me a very vertically stretched cube root function. Okay, x-intercepts, still 0, 0. Y-intercepts, still 0, 0. Domain, always all real numbers for these. Range is always all real numbers. And this one is still going uphill, so that's negative infinity to positive infinity. It's never decreasing. In order for the graph to decrease, the a value would have to be a negative number, like that. And what that would do is it would take our cube root function and it would flip it to go this way instead of the increasing direction. Notice then we'd be going downhill the entire time. Okay, so in this video, you learned how to identify the domain of a square root equation, so you didn't have to graph it all. Then we graphed the parent functions for square and cube roots, and then we used a, h, and k to do lots of transformations to get the family of functions. Go ahead and try those Now You Try problems.